Mean stock expectation over discrete PDF is what we're going to see in this lesson. Please don't forget to subscribe to the channel. Now, this is not by new. If you see new, this is the Greek letter called new. It means we are dealing with mean. The mean over discrete with a PDF list of random variable capital X given by, so when you have small x, if it's only one value of x, you just get the probability of that value of x, you multiply it. But because we have seen that these PDFs have more than one value of x, you sum all those values of x times their probabilities, then you sum them, you get the x with its corresponding probability of that x. Then after, you sum all of them. Similarly, if you have the expectation of x squared, you get x squared multiplied by that probability of that x squared. Then if you want for many, you sum for all those x values, then we sum, we get x squared times their probabilities. We have some properties of expectations. I did expectation here. We have a and b as constants. These are real numbers, of course. E of a, expectation of a constant, is that constant. Then expectation of a constant that is a variable x. This means that we pull out that and then we get that. This a is removed as a constant. And so if we have this whether plus or minus, okay, let me include the idea, even if it's plus or minus, the idea remains the same. This one comes to this, also comes to this, the distributive property there. Then you remove this one out, mainly this is this property, and the e of this we say is a constant. Let us see an example here. A discrete random variable has a PDF, a probability function given by this. Now this one means for x values which are 0, 1, 2, and 3, this is their function. 0 elsewhere, so anything which is not 0, 1, 2, 3, its probability in this function is 0. That's what it means. So find the value of constant k. So it means that now we first get the probabilities of these individuals. So when you know that we have seen that our probability of x is given by k into 1 over 2 power x. So we say when our x, small x, is 0, what do we have? We have probability of x equal to 0, and when you put here 0, we have k, half power 0, anything to power 0 is 1, so here we shall be getting a k. When x is 1, we shall get p of x equal to 1. We put where there is x, we are putting 1. So we have now k into a half power 1, which will be anything power 1 is that something that is this. We get k over 2. When x is 2, have our probability of x equal to 2, which will be k into now a half, now power 2, which will be k. When we power 1 power 2 is 1, 2 power 2 is 4, which will give us k over 4. Then when we have our x equal to 3, we have our probability of x equal to 3, it will be k into 1 over 2 power 3, which will be k over 8. This 2 power 3, we get 8. So these are the probabilities. Now we need to find these values of k. So the idea there is very simple, that when we sum all these probabilities for all these values of x, we shall get a 1. So now these are our probabilities. So meaning when you add k plus k over 2 plus k over 4 plus k over 8, we expect a 1. So the LCM is 8. You'll see that when we get the LCM, when we simplify all these, the LCM, okay, if you have come here and say my LCM is 8, this is over 1. This goes here, so we have 8k. 2 goes here, 4k, plus 2k, then plus k. The whole is equal to 1. And up you see, we have 12, 13, 14, 15. So we have 15k over 8 equal to 1, implying that our k, cross multiply, we get 8. divided by 15. So your k is that. So that's the value of k. Implying that after getting the value of k, now we can come and get our expectation. Now here, you draw such a table. So you put here the values of x. The values of x you have are 0, 1, 2, and 3. Is small x. Then you put after that, you put the probability. When x is equal to small x, their corresponding probabilities. When it is 0, you have seen is 8 over 15. This one is 8 over 15. When x is 1, it's k over 5. I mean k over 2. So k over 2 the same as our k here. We have 8 over 15 times 1 over 2. This is half. By this one, by this 4. So that is half that. So this one is going to give us 4 over 15. So when x is 2, when k is, when x is 2, we have k over 4. So we will have k times a quarter, which would be 8 over 15 times a quarter. And this one by this 2. So that's why I'm having 2 over 15. This 2 over 15. When it's 1 over 8, so then I put is that the k times 1 over 8 will be 8 over 15 times 1 over 8. This one will cancel, so we are having 1 over 15. So that's how I got those probabilities there. So when you substitute them there. Now, I need now expectation. Say expectation, you need sum x times their probabilities. So you get the x, then you multiply them with their probabilities. This times this, so x times its probability with the corresponding probability. So this times this, we get 8. We get 0, sorry. I was saying 8 over 15 times 0, which is 0. So this times this is 0. 1 times this, we get the same. 2 times this, we get 4 over 15. Then 3 times this, we get 3 over 15. Now, don't reduce them. That is very easy to add. So when you sum, now you need to sum all these probabilities with the product of these probabilities with their corresponding values of x. And then sum them, the LCM will be the same. In simple terms, we are summing this plus this plus this. So we shall be getting this is 8 plus 3, which is 11 over 15. Because they are having the same LCM. That's why I'm very, very able to get that value. Then it's that now from there, I come and I indicate that my number 1, my expectation of x, which is given by sum for all x values, probability of factor x equal to x, is given by 11 over 15. So that's my expectation there. Okay, well now we come to number 2. You want us to get now x squared. And we said that to get x squared, you need to multiply the parameter with x squared. And meaning we create a column of x squared. When you square 0, you get 0. When you square 1, you get 1. When you square get 4. When you square this, you get 9. Then you multiply them still. But we're multiplying this with the probability. So this times this, we get 0. Now you are multiplying x squared with the probability of x. So this is x squared and this is the probability. So this times this, I get 0. Now this times this, I get 4 over 15. Now this times this, I'll get 8 over 15. Then this times this, I'll get 9 over 15. In simple terms, we are done with multiplying. Then after that, we need to add all these things here. Okay, we start the LCM is the same, so it's as simple as adding the numerator. So this plus this will be 12, plus this we shall get 21 over 15. When we sum all flats. So now, these are now 1 and 3. My expectation x squared will be, say, is the sum of x squared with their corresponding probabilities. And you've got 21 over 15. Then over number 4, you see this one is very easy. I need e of 2x minus 3. You say now, you can use the first handle it is in this property here. So this will be the same as e of 2x, then minus e of 3. As simple as that. This negative. There. So this will be now 2e of x, then minus 3. And this will be 2. We got our e of x as 11 over 15, then minus our 3 there, which will give us, this will be 22 over 15 minus 3. And there you will get, this will be 45 over 22 minus 45 over 15. And you simplify this, you get negative 23 over 15. And that will be the answer. So that's how we handle expectation. Now we are going to see how we handle variance. See you there.